I was told the video from Friday had music playing in the background, so I apologize. I'm going to try to make another quick 5-minute video for students who missed last Friday, which would have been the 16th, I believe. So we started talking about margin of error, so I'll pause it if you need to put that in your table of contents. I then went through, see if I can do it justice here. I know that it's been a couple days, but I talked about the question of interest that we did with the activity. Now, I know not everyone got to do the activity, but I asked my colleagues to help me to gather some more data just because we didn't have time to waste in class. So what we did is we had a big bucket with a population in it. We took out a sample of 20 right here. The purpose of that sample was to give us information about the population. The information we needed was what percentage of the dots are purple. We then plotted it, and we were going to draw some conclusions. We talked about that in class right now. So if you look over here, I have the graph, okay, right here. I have everyone's sample plotted on here in the percentage. Now we're going to draw conclusions about that population. I asked, estimate the true proportion of purple dots based on our sample. Most people guessed anywhere between 30 to 40%. Why? Well, most of the dots stacked up around there. Then we talked about what's the purpose of that random sample. Well, the purpose of that random sample is to eliminate bias, right? We want the sample representative of the population, the chili example, okay? You want to stir the chili before you take the bite. I then gave the actual truth about our population. Our population, 33% right here, of the dots were purple, okay? Right here, the sentence, I think the population percentage of purple dots is blank, was your guess earlier. You don't need to write that down in their notes. Okay. Now what I talked about, and again, pause where you need to write down the notes. Results from a random samples come with a margin of error that sets bounds on the size of the likely error. So statisticians don't ask 1,000 people who's going to vote for Hillary multiple times. They ask one sample of 1,000 people. So they get one of these little dots, right? And then they predict the population based off of that, okay? So they say, I think 45% of people are going to vote for Hillary, and it's usually within a margin of error of 3%. That means I could be wrong. My sample says 45%. But the truth will be somewhere within 3% of that, okay? So then I used that for our, let me get my highlighter out, excuse me. I used that then with our example with dots. I said someone here got 50%, right? So they would say, I think 50% of the population has a purple dot. Well, the truth is 33%. Well, what you notice is I calculated the margin of error for you. Oops, sorry. And that margin of error is 22%. So if you draw a line out this way to 22% and you draw a line out that way to 22%, I think 50% of the population is a purple dot within a margin of error of 22%. And you'll notice the truth is in that interval right there, 33%. That's the purpose of a margin of error. Then finally, we talked about variation and the importance of variation. Predict what this graph would look like if we used a sample size of 40 rather than 20. Now, right here, when I highlight it, this is something different, but this is talking about what's going to happen. So if I have a 38% statistic, plus or minus a margin of error, you can look at my interval from 35 to 41%. But now look at this one. I have 38% statistic with a margin of error of 10%. What do you notice about those intervals? Well, hopefully what you're thinking right now is this interval is much, I don't want to say precise, but it's a smaller interval. There's not as much variability there, okay? There's not as much variability. So what can we say? Sample 1 had a larger sample size. What I wanted you then to put in your notes is, why do we want a larger sample size? Sample size is dealing with replication. Replication is important for controlling variation, that variability piece. As the sample size increases, we should observe less variation. Then I finally just said, think of it this way. It's plausible that if we flip a coin 10 times, you could flip it the tails 8 times. There's going to be a lot of variation with a sample size of 10. But if we flip it 100 times, and 80 of those are tails, there's not as much variation. So now what we can do is we can draw a conclusion and we can say, something must be up, okay? Something must be up because this margin of error here is only about 10%, okay? Right? That doesn't even capture 50%. If you need more help with this idea, let me know and I can go in depth with you about this. Again, this is what you missed on Friday. I apologize for the music playing in the background, and hopefully this can give you a better idea of what we talked about. Like I said earlier, pause this where you need to. Thank you.